coefficient of determination. For our class, we really don't need to know that much about it. If I say r squared, I mean this one sentence. Hands down, if I say r squared, I mean this one sentence. This is on your blank sheet, not your college football sheet. Blank percent of the variation, this is your r squared. This is whatever your y is. So we are predicting our y. So the percent that we are wrong, or percent that we can be wrong by, the percent of variation in y can be explained by the line we just came up with. And this is least squared regression line. We use that a lot. Of y on x. Which I don't have a place for you to write this on the college football one, do I? Interpret.
What was our least square regression?
Your equation is your least squared regression equation.
The A.
Yeah. I didn't give you a place to write interpret r squared, right? So if I asked you to fill this in right here, your r squared is 0.8625. Well, what is that as a percent? 86.25. So 86.25% of the variation in, what's this? Points per game can be explained by the least squared regression line of points per game on yards per game. If I wanted to write that in. Alright, now here I'm just writing generic of what we've already written. I'm trying to go a little bit quicker to finish this. Y hat equals a plus dx. We've already written this down, but the specific one, and I used to do this, but people didn't understand that meant you should actually plug in numbers. Which two do I plug in numbers for? And then we define my x is something, my y hat equals, what's my first word? So that's just a generic of what we just wrote.
Wait, the thing that we wrote a second ago, the r squared, why does it say y on x?
It should, don't worry about that.
Okay,
That always confuses people. Don't worry about that. It's y created from x, like it's actually very explanatory. You don't have to worry about that part though. Alright, so slope and interpret slope. This is your b in your equation. Raise your hand if you know, you can understand what the word slope means. Raise your hand if you know what slope is. Dear God, please raise your hand. Somebody tell me the definition of the word slope. Alright, so tell me what it means to interpret what slope is.
Interpret the change in life.
This kills me because all of you hopefully understand what slope is, but you can't tell me what it is. And I get that, like, it happens every single year. As your x changes by how much? What's going to happen? Your y changes by this much. So you understand what it is, but putting it into words is, for some reason, I guess we just didn't teach that. So for every one increase, what's going to go here? Now, does that mean every single time our x increases by 1, it has to increase by this much? So this is important because it's not that it has to every single time, it's that that's what we predict it to do. So we predict the what? Why would I add this weird word right here? Or, right. Now, is this always going to be increase? This one actually is, because if our x goes up 1, our y might go down 1. If I switch this to decrease, then it would switch what that is. Honestly, sorry, about slip. For an individual in the population. I'm going to go ahead and write interpret y-intercept on the same slide just in case people are still writing. So this is your A in the equation.
Oh, where'd you go? Where are you?
Right below it. I just didn't switch slides.
Oh.
So what does it, now this one you guys are usually better with. What does it mean to be a y-intercept?
Where?
So where x is 0, that's what we predict y would be. So if an individual in the population and I want to make sure that we have these generic ones really good, and I can type up the ones for our today example really quick, easily. Now, I'm writing had 0x. Some of the wording for this might make more sense to say had no something. That's fine. Then we predict, again, it's not a definite, it's just a prediction from the equation. We predict the what? Would be about. Now, I need to write a little bit with this one. Let's say, what was our y-intercept for this problem? For our football problem? What was our y-intercept for football? Negative 11 point something. So that means, let's fill this in. I'm going to write it later. If a team in the college football, blah, blah, had 0.
Wait.
I'm going to write this in a second. Had 0 yards per game. We predict that the points per game would be about. How much does that make sense? None of it. Number one, if a team had 0 points or 0 yards per game, I don't know how they did that, but they can't have any points per game. Check for the again or other things. And it's definitely not okay to have a negative points per game. So this doesn't always make sense in context. But it is still the correct interpretation. That's supposed to say interpretation or whatever. Now, there is one word that's really important that we'll talk about eventually. How in the world, if our numbers are so good and our line is so good and our line is so strong, why do we get such a terrible estimate for our y-intercept? Other than the fact that math is not whack. What? The question? How can this be so good, but that be so bad?
We don't have any.
Where is this?
No.
really far away from where I graph things, right? So here's 650, here's 250, so I'd be about here. So I am estimating way outside of any of the values that I had. So should it necessarily work really well there? Now, if I estimated for like, how many points per game would a team have for 400 yards? Do you think that would be a pretty good estimate? That's probably going to be a pretty good estimate. But if I am estimating way outside of the realm of my X values, I don't know if y'all have room for this. I'll write it later. It's called extrapolation. I'll write it later because I don't want to not talk about it. All right, so let's finish out. Oh, go ahead. Writing our examples. All right, so our slope is which number? Exact number? So in context, for every what? So every one increase of yard per game, that sounds weird. It's okay to like rearrange that English-wise to make it make more sense. I would probably write this one for every increase of one additional, or one for every one additional, whichever way you want to write it. For every increase of 1 yard per game.
So that makes it sound like instead of doing one increase, we're going by 1 yard.
We are increasing by 1 yard per game. Every time that a team gets 1 more yard per game. What? What comes exactly after that? We predict. What are we predicting to change? I have a decision here. It's either what or what. And it's going to be increased because my graph is positive, my slope is positive, my R is positive.
Instead of 2, is it if you just said like will or something?
Yeah, that's fine. But as long as you said yeah.
Increase by about 20.
And then what?
Why is it points per game? I thought it was individual and population.
That's units. This is just units.
Individual and population.
No. This is those units. This is weird to where our units happen to be our variables.
Oh, we haven't written the 4.
Right. In this one, if you did write points per game, because you wrote it here, I wouldn't cut off for that. But sometimes it makes more sense where it's like, if your height increases by something inches, it makes more sense when your units aren't the same as your variable. For a 2015 college football team in SEC, ACC, I probably should have switched it to where I didn't have breaks every time. Or Big Ten. Big 12, sorry. I said 12 root 10. So opposite. And then our last one, which is interpreting our y-intercept. If a team usually we're going to write something off to the side and not have to do this every single time. But for right now, I want you to get in the habit of this. For a 2015 college football team in SEC, ACC. And then what?
Has 0 yards per game. We predict.
be about, and then negative 11.1085. And again here, it's just weird that our units is the same as our variable.
How do you know our y-intercepts?
Your equation that we did in our calculator. Like the calculator gave us, we did that. Alright, I'm gonna need your help.